Hello everyone, welcome to Almighty Tricks. Today we'll be solving one question from LeetCode, that is optimal partition of string. So in the question, one string will be given as an input, and we need to create substring in a manner that all the character of that substring will be unique. Okay, and we need to return the minimum number of substring, how many number of substring we can create with unique elements. Okay, and the constant is given, the length will be 10 to the 5, and the string will be like English lowercase letter. Okay, let's see how we can solve this one. A B A C A B A. Okay, so the question is given, we need to have unique element, unique character in substring. Okay, and the constant is given, length will be less than equal to 10 to the 5, and also a string will be like lowercase English letter. Lowercase English letter. So how many lowercase English letters are there? There are 26, right? 26 lowercase English letter. Okay, let's see how we can solve this one. So let's take this example. Okay, so I'll consider A first. Okay, as A as a substring. So I need to maximize. Let me maximize this substring. Okay, so I am getting A, then I'll get B. Okay, I'll put B here, and then I am getting A. So I cannot put A because we need to maintain the uniqueness, right? So I'll not add this A. So here I'm getting one substring. Okay, let's take another one. So I'll start with A from here, A. Then I'll add C because C is not present in this substring. So I'll put C. Then I'm getting A. Then I'm getting A. A is already present in this substring, so I cannot add that one because I need to maintain uniqueness. Then another here, A. From here I'll start, right? Then B I can put because B is not present. Then I'm getting A. A is already present, so I cannot put. So this will become another substring. Now I need to start with A. So A is there. Then there is no character. There is no character. So from here I can get the output as 4. Okay, hope you understood this question. Let's understand how we can solve this. Okay, so the number of lowercase letter is 26. Okay, fine. Let's take one example. Let's say I have one string with unique characters A, B, C, and D. Okay, A, B, C, and D. It means what? I can consider whole string as a substring, right? I can consider whole string as a substring. So here output will be 1. Got it? Okay. Let's take the previous example and we'll dry run. Okay. So input, let's say given previous example A, B, A, C, A, B, A. Okay, this is the input. Okay, let's say S. Okay, so another thing is here we are checking the uniqueness, right? We are checking whether age. So whenever a duplicate A is coming, so we are checking whether A is already present or not. Okay, so we need to have one data structure. We'll come to that data structure later. Okay, so we can have one data structure which will store all this data, as well as it will give the uniqueness, whether it will give like whether A can add in this data structure or not. Okay, those kind of data structure we need to use here. Okay, later we'll come to that data structure. Okay, so let's do one thing. We'll go from left to right, from 0 to end of the string, 0, 1, 2, 3, 4, 5, and 6. Okay, let us let us go from 0 to 6. Okay, let's say I is given. Okay, and I can have one counter where I can store the answer, counter. Okay, so initially counter will be 1. Why 1? Because let's say example, let's take this example. Okay, let's take this example. Say all the character of this strings are unique, so I can consider this as a 1, right? So similarly here, oh, so this can be a substring. Okay, this can be a substring, but some duplicates are there. Okay, but here if you say, if you check, this is a substring with unique character, so the answer will be 1, right? So first of all we'll consider with 1, counter will be 1. Okay, let's start from 0. When I is equal to 0, okay, when I is equal to 0, so I'll check in this data structure. Let's say this is the data structure. Okay, I'll check in this data structure whether this A is present or not. If it is not present, then I'll put A here. Okay, fine. Then I'll increment I, then I'll come to 1. So when, so 1 index is B character is present. I'll check in this data, B is present. No, B is not present, so I'll add in this data structure B. Then I is equal to 2. Okay, now observe. So in the 2 we have A, right? But this A is already present in this data structure, so I'll check in this data structure whether this A is present or not. Yes, it is present, so I cannot put. Okay, so it means what? So it means what? I am getting duplicate means I can consider this as a what, substring, right? So I'll increment to 2. Okay, and as well as when I get the substring, that time I'll remove all the elements from this data structure. Okay, and I'll put this A, I'll put this A here. Okay, now increment to 3. Now C is not present in this data, so I'll put C here. Okay, now come to A. Okay, A is already present. It means what? I am getting one substring here, so I'll increment to 3. Okay, and I'll remove all the previous elements. I'll remove from here. Okay, then I'll add this A. Okay, I'll add this A. Now increment, so I'll increment. Okay, this is 4. Okay, now come to 5. Okay, so when I is equal to 5, so character is B, right? So I'll check B is not present, so I'll add B here. Okay, and plus increment I is equal to 6, so A is coming. A is already present here. Okay, so I cannot put, so I can consider this as a substring, so I'll increment to 4. Okay, now I'll remove this. Okay, and I'll put 6 in the data structure. Okay, so now comes to this data structure. So which data structure we can use? We can use here like set we can use, right? In the set it should be a character type. Okay, so we can add the character, we can remove all the characters, right? And we can get, or we can check whether A is already present or not with order of 1 time, right? With order of 1 time we can check. Okay, so we can use the set data structure here. Okay, now let's understand what is the time complexity of this algorithm. So time complexity will be order of n. Why? Because we are going from 0 to 6, right? Means 0 to length of the string, so it is order of n. What is the space complexity? Space complexity will be order of n. Okay, as we are using this set data structure, extra space we are using. But one more thing here, space complexity is not order of n, it is order of 1. Why order of 1? Because at max we can add the character 26. Total number of character we can add 26, because we are not adding any duplicate data, we are adding only unique characters. So we are using lowercase English character, right? There are 26 number of lowercase English characters are there. So this is kind of a order of 26, but it should be order of 1. Okay, so the space complexity is order of 1. So finally time complexity is order of n and space complexity is order of 1. Okay, so let's check the code. So code will be very simple. So what I did here, I have one variable with the length s.length, then I have declared one has set here. Okay, so initially the count should be 1. Okay, I'm going from 0 to n. Okay, I'm going from 0 to n. N means this length of the string. then here I am getting the character s dot character at of I. Okay, now I am checking if this set has this character or not. If it is there, then I'll remove all the character present in this set. Okay, so I'll remove and I'll increment the count because I am getting the substring here. Okay, and I'll add that character. Okay, I'll add this character in the set. Okay, and I'll return count. Okay, so hope you understood this approach. Thank you for watching this video.